we out here doing gang stuff. So we're doing a related rates problem, and we'll be measuring. One of us will be walking this way. One of us will be walking this way at different speeds, and we'll be measuring the distance right here that it makes.
We are out here grinding on a nice April morning. April. Stop.
Shit, here we go. Damn. We out here grinding, Go. Ready? Hello.
All right. Those videos you just saw, we took a reference point here, and Pat, my brother, walked this way for 10 seconds, and then myself, I walked this way at a faster speed for 10 seconds, and now we're really gonna find what that distance was and how it was changing while we were walking at those different speeds, as if we started walking at the same time. So my brother Patrick walked 10.125 meters over 10 seconds, and I walked 15.75 meters over 10 seconds. So
we did this math over here.
We did do this math over here.
And we found that the meters per second we were doing is 1.575 for Cal, the elite runner, and 1.0125 for me, the slow runner. So now I work this out, and I find that dx over dt is this, dy over dt is this is me, this is Cal.
We are walking at constant speeds during our strenuous workout of 10 seconds.
So over here with the Pythagorean theorem, and then I translate in terms that we can work with, x representing me, y representing Cal. Then I'm in the process of derivativing this formula, and so it's 2y over dy over dt equals c squared. So now we know that c squared equals 18.72 meters, and we know that, it's
the highly intellectual Patrick.
Gentlemen, you are witnessing a math creation. In the math communication, we call this a eureka moment. Basically, I worked this whole thing out. I solved world hunger. So you get over here, you get the Pythagorean theorem, you work it out, you put in numbers you understand, you derive it, and then you get all of this right over here. And then you plug in the numbers that you know. We know that dx over dt, that's the rates. We know dy over dt. We know dc over dt is what we want. And you plug in the two x's over here. You multiply these starting numbers, and you plug in the rates at which they change. And you plug in 2c, which is double the length of the end. And then you work out all of the math, and divide it, get it all on one side, and you work it out in the rate at which this is changing at the very end is 1.8727 meters per second.
Genius.
Case in point, give me a doctorate. Let me get this dissertation. This is my dissertation.